Welcome back to our Inventor Nastran demo series. In this final video, we will run our simulation in Nastran and post-process the results. We will evaluate the bomb missile stress, displacement, and safety factor. Make sure to subscribe and hit the notification bell to stay up to date with our latest contents. Okay, so let's get into Inventor. Okay, so this is the model that we prepared in the previous video. We had a cantilever beam with some fixed constraints at the end, an opposite load of 1000 newtons at the end. So model is fully prepared, so we're just now ready to go into the top, solve, and click on run the simulation. Okay, so the simulation is run and it's all good. So we're gonna just click on OK. So we can go being able to analyze the results. Okay, so we will go into subcases and the node results, and we will see the 4 results that are available by default. So bomb misses, as we can see in here. And then we have the displacement that is available and the safety factor. Yeah, safety factor, and being able to see the deformed part and the comparison against the original position. Okay, so let's go one by one. So let's go back into bomb misses. So with the bomb misses stress, we can see a full distribution of the stress and showing the maximum levels of stress at the close to the area where we had the constraint and the minimum values at towards the end of the beam. The maximum level of stress, as we can see here, for the bomb misses stress is 141 megapascals. If we want to analyze the behavior of the compressive and tension stress, yes, we can analyze. We can get those results by checking on the maximum principal stress and minimum principal stress. So let's click in here, maximum principal stress. So we can see that the maximum principal stress shows on this area and show all of the stress that is in tension. For this cantilever beam, we're gonna have that the top face of this beam is gonna be in tension on this area and the bottom in compression. If we want to evaluate the compressive results, compressive stress, we just click in here and we will see that at the bottom of the beam we will have the minimum values of stress 189.6 and the top 58.02. Okay, in terms of the displacement, yeah, we have that the maximum value is 2.2 millimeters, and let's say the safety factor is 1.46. If we want to get additional results, we can go in the command options. So just do double click in here, and then the plots results dialog box opens. And from here, we have different possibilities to analyze our results. So let's get in here. You will be selecting the type of data, result data. And from the result data, you have the different options in here. So let's click in bomb misses. That was the one that we saw before. And from here, you also can get the selection of the different type of displacement. When we select type, we can analyze the displacement in different directions. Then in the deform options, we can see the displacement in also different directions, and we can define in here a deformation scale. Yeah, so we can have a percentage of in here it says 10%. Let's go be higher, yeah, or the actual value, as we can see here. So this is a representation of the 2 millimeter that the that this beam will actually would displace under those loading conditions. So now I would like to show the behavior of an animation with the values of the stress. So let's go into bone business, and I'm just gonna go in here and click on animate. Yes, so you can see certain small displacement there. If we want to see a with kind of bigger impact, so let's see with 10% of the formation scale. Yeah, that looks much uh, uh, better in terms of of the the results. Okay, so I think that is it for the demonstration of this static analysis Inventor Nastran workflow. And we have successfully completed our static analysis using Inventor Nastran. So thanks for watching, and don't forget to subscribe for more tutorials. Leave a comment below if you have any questions or suggestions for future videos. Thank you.